Imagine a huge assembly with an endless number of stars, planets, and moons working together brilliantly. In any case, there is one element of this ensemble that has long astounded space experts: exoplanets. Planets that are located far out in the Milky Way and are not a part of our solar system are known as exoplanets. You may be shocked to learn that there are exoplanets amid the vast array of galaxy objects that are so strikingly identical to Earth that they might be the divine twin of our planet. We enter the picturesque region of Proxima b, which is only 4.2 light-years away. In our attempt to comprehend these heavenly secrets, the James Webb Space Telescope is creating a stir. Imagine a day when your thoughts traverse the Milky Way, the enormous expanse of our reality that is home to almost a quadrillion exoplanets. There are 15 zeros in the number. To put this figure in perspective, we wouldn't only fill the Grand Canyon if each of these exoplanets were the size of a grain of sand. We would have enough to construct a Grand Canyon 2.0, another earthly marvel that would stretch for a very long time. The fact that around 20% of these magnificent things have been determined to be Earth-like in terms of geology and atmospheric structure often surprises people. This indicates that there is a 1 in 5 possibility of running across a duplicate of our planet, and the tale doesn't stop there. An extra 4 billion moons, or rocky satellites similar to our own, may exist alongside these planets, caught in a gravitational dance with their parent planets. There are infinite options in the cosmos if you've ever wondered whether you might locate another celestial body that either houses or could support life. Now that we've set out the canvas of unthinkable size, now is the moment to present the professional instrument ready to depict its complex subtleties. The Webb Space Telescope James, with its precisely calibrated magnified center lens, this celestial Sherlock Holmes outperforms even the most sophisticated optical devices. We're not just discussing any lens. Imagine the amazing detail it can discern in even the smallest flicker of a star billions of light-years away with its 6.5 m wide main mirror, which is 2.7 times bigger than Hubble's. Then examine the subtleties of planets in orbit. The James Webb Telescope is groundbreaking not just because of its capacity for observation but also because of its sophisticated technology, which includes sophisticated sensors and spectrographs. These technologies are capable of far more than just observing. They are able to assess and interpret the unusual light that celestial bodies produce or reflect in order to ascertain the atmospheric conditions, density of chemical composition, and even mass. By assuming the role of a space scientist, it may ascertain if a planet has oxygen, organic compounds, or water. The James Webb Space Telescope transforms into a scientific marvel rather than only an observer. It is more than merely an advancement over Hubble, its predecessor. It's a quantum jump. If you were astounded by Hubble's findings, get ready for a genuine celebration of space exploration. It is worthwhile to concentrate on a single star system when we turn our attention to the universe's vast environment. Proxima b, the angelic performance. Since its discovery in 2016, this puzzling planet has captivated scientists and anthropologists alike with its unpredictable and dramatic Shakespearean nature. The first reason for the commotion is that Proxima b is just 4.2 light-years away from Earth and is located in our galactic neighborhood. To put that into perspective, you would reach your destination in little over 4 years if you could travel at the speed of light, which is about the same length of time it takes for your favorite television shows to get repeats. But let's examine in more detail why this planet is so important. Since the universe we are discussing is more than 93 billion light-years across, discovering a planet this close and so promising for scientific study is like finding a diamond in an Everest-sized mountain of rubble, a gem that might hold the secrets to life itself. Proxima b is a colorful thread in the universe's vast fabric, providing us with potent hints that may completely alter our understanding of habitability and extraterrestrial life. Researchers are intrigued not just by Proxima b's close vicinity but also by the strong indication that this planet could not be Earth-like. It might be Earth 2.0. Imagine waterfalls meandering ose and enigmatic like the Mariana Trench. Proxima b is situated comfortably in what space scientists refer to as the habitable zone of its parent star, where the environment is just suitable for liquid water to exist, neither too hot nor too cold. However, we must take into account a couple of Proxima B's quirks before we get too excited about visiting. First of all, a day on this meme exoplanet lasts an incredible 11 Earth days. Mornings come gradually rather than all at once. Although this may seem perfect, the lingering sunsets create beautiful hours that photographers could only imagine, which present important issues about human adaptation and the environment. If life existed there, it would be both painfully strange and tantalizingly familiar. How would our biological rhythms adapt to such lengthy days? Would we need to feed 3 or 4 times in a single planetary day? Would we sleep differently? Nature seems to be providing us with a puzzle box to test our comprehension of what it takes for a planet to be really livable. How can we get precise information about a country we haven't visited? The James Webb Space Telescope provides answers. It is more than just a telescope, in the manner of a cosmic Swiss Army knife. In the empty space, it serves as a comprehensive research laboratory. Modern technology allows cosmologists to use an array of scientific tools that would make a CSI lab seem antiquated to not only detect planets but also analyze their atmospheres. The Webb telescope examines light that is reflected and emitted by far-off planets using sophisticated spectrographs. Each substance in the atmosphere of a planet absorbs or releases light at certain frequencies. Scientists may remotely sample celestial objects by examining these patterns to determine atmospheric pressure, density, and the possible existence of vital life-supporting substances like oxygen, water, and organic carbon molecules. Astronomy is just one aspect of space science. It's galactic-scale forensic inquiry. We actively search for hints by examining the atoms and molecules that make up these other universes rather than passively waiting for them. The James Webb Telescope is a highly specialized cosmic investigator and transportable laboratory all in one. It is more than simply an eye in the sky. It transforms our beliefs about other planets into testable experiments that redefine our understanding of life beyond Earth. And just when you believe you have revealed the most beautiful layer of this cosmic onion, the plot changes once again. Like any great science fiction thriller, Proxima B delivered a surprise to the James Webb Space Telescope. An incredible signal that went viral on social media and in classrooms known as a possible technological signature. It was an elaborately planned electromagnetic discharge that may reveal the existence of a highly developed civilization. At the pinnacle of a discovery that had the potential to fundamentally alter how we see the world, humanity's collective pulse appeared to halt. Could the signal be real evidence that we are not alone in the universe? It vanished without reoccurring as swiftly as it arrived, leaving behind a tangle of unsolved questions and brewing theories in addition to a breathtaking quiet. The single expedition left Proxima B with a persistent air of mystery, igniting intense debate and conjecture. Was it really a fleeting cosmic aberration, often referred to as an endless arrangement, or something else deliberate? A coded message, or perhaps an indication of alien intelligence? Was it an isolated incident, or was it a part of a larger, more puzzling narrative? The story of our cosmic journey is far from done, however. New chapters are yet to be written, and this time, Harvard scholars are spearheading a change in viewpoint in addition to traditional experts. They are stepping it up and converting the James Webb Space Telescope into a sort of enormous night vision apparatus as we continue our search for extraterrestrial life. They intend to look for artificial light sources in both the dark and illuminated regions of far-off worlds. They are not satisfied with just examining the signals and anomalies we have already discussed. We're investigating astounding possibilities, including the potential to find artificially created cities that shine in the dark, akin to bright SPS-structured photonic systems. Imagine seeing discharges of luminous light. It may be a metropolis that is bustling with a highly developed human civilization that is radiating its light into the vast seas of space. Beyond the current excitement in Proxima B, the search for alien life takes on new dimensions as we continue to uncover the universe's mysteries. Our ambitious mission delves further into enormous, uncharted areas of space. This quest is motivated by both advancements in technology and a strong desire to understand our place in the universe. Due to developments in cosmology and space research, a variety of exoplanets with the potential to support life have been found. Our capacity to find and investigate these far-off planets has increased because of tools like ground-based observatories and the James Webb Space Telescope biosignatures. The hunt for biosignatures, or indications of life, is one especially intriguing field of research. These indicators may include atmospheric gases such as carbon dioxide or methane, which, in the correct situation, may indicate biological activity. The capabilities of the JWST go beyond simple discovery. Its sophisticated detectors can determine the exoplanet's atmosphere makeup, which helps identify worlds that could be habitable. The telescope's data may provide fresh insights into the ecosystems of far-off exoplanets by revealing their intricate dynamics and processes. Proxima b continues to be a crucial area of research that will direct us into the future of space exploration and alien discoveries as our exploration efforts progress. The hunt for alien life has emerged as a key area of scientific investigation as the James Webb Space Telescope deepens our knowledge of far-off planets. The techniques and tools we use, like analyzing the composition of the atmosphere, may provide the most direct proof of circumstances necessary for life as we know it. This search involves more than simply locating familiar, Earth-like settings. It also involves taking into account the enormous variety of circumstances that might support the emergence of life in unexpected ways. There are significant ramifications for mankind if alien life, or even merely indications of it, is uncovered. It broadens our perspective of life's potential and challenges our belief that we are special in the cosmos. Imagine learning that life has evolved in environments significantly different from Earth. Is it possible that life on other planets has evolved to withstand very high or low temperatures? Could it flourish in areas we previously believed to be uninhabitable, such as poisonous atmospheres or even a shortage of water? These questions push the boundaries of cosmology, biology, and philosophy. Even if there is no life on Proxima b, the possibility of habitability opens the door to investigating other star systems that might support life. As we continue to collect data from this far-off exoplanet, we also learn more about the universe as a whole, improving our instruments and methods to detect life throughout the cosmos. Proxima b, with its potential for habitability, serves as a beacon in this quest. Finding biosignatures or technosignatures that indicate the existence of or the potential for a sophisticated civilization is one of the most fascinating possibilities. The quest for artificial light or other technical signals might completely change our understanding of extraterrestrial civilization, even if scientists are still hesitant to make inferences from unusual signals like the one from Proxima bb. The idea that we could find infrastructure or cities on other planets opens up new lines of investigation that combine astronomy with the hunt for extraterrestrial civilizations. This dynamic and ever-evolving study is fueled by cooperation across several disciplines: biology, engineering, astronomy, and artificial intelligence. As technology advances, our capacity to more precisely examine the cosmos will only increase. Future initiatives aiming at examining even more distant star systems and exoplanets are already planning additional missions to use Webb's capabilities. What does all of this imply for space exploration going forward? As we push further into the cosmos, we encounter an exciting potential. The study of a cosmic environment that is linked and teeming with life-giving potential. Every new finding advances our knowledge of our position in the wide universe, whether it is the atmosphere of a far-off planet or an odd signal from a star system. However, every response raises fresh queries that call into doubt our most fundamental beliefs about the cosmos, life, and everything in between. Finding something familiar is not the only goal of the hunt for extraterrestrial life. It's about accepting the unknown, stretching our creativity, and realizing that we are but a tiny component of a vast and mysterious cosmos. The future is out there waiting for us. There are several chances to reconsider what we now understand about life, the universe, and exploration. The finding of a second Earth or the signal from an extraterrestrial civilization could not be the story's conclusion as we go. It could just be the start.